Då tror jag att vi är live. Fint. Hi, and welcome to yet another session with Azure Cognitive User Group. Today we're gonna talk about AI and cognitive services. Peter will present and show some cool stuff. And hopefully you will enjoy it and learn something new. The agenda today is simple. We're gonna do some welcome and intro here. And then I'll hand it over to Peter and he'll go through all of his cool stuff. And you probably get some cool links at the end, so please stick around. A little bit about us here at Azure Skåne. We are now over 870 members, and that's pretty nice. It's all about learning, networking, and having fun. And everyone is welcome, regardless if you have any skills in Azure or not, or it's all about networking and have fun. We are 3 people in the Azure Skåne crew. Myself, I've been working within IT since 2000, and currently I'm working at Avanade, Denmark as a cloud engineering manager. And I am an Azure MVP. And I think you, Johan, you're also online.
Yes. So hello, I'm Johan, and I've worked with data management and Microsoft technology for about 25 years. I worked for some really large companies and some small companies, and now I'm running my own business. And I've been using Azure since the very, very beginning, and used it quite a lot.
And then we also have Magnus Mortensson. He's not present at the moment, but he's also a member of the Skåne crew. If you're attending, if you join the sessions, please use the hashtag Azure Skåne and share your insights, your thoughts around it. It's always nice to follow up and see any communication around it. This event is sponsored by Microsoft and Foo Café. So big thank you to those. And now to some cool stuff. Microsoft has built, in collaboration with Engine, a blockchain badge that you can collect if you attend these events. And we have a winter learner one. So please scan this one. And you'll get a link in the chat also. So collect your badge. Eventually, when we can meet physically, you can show all your collection and probably earn some cool swag or something. It's a fun thing. What we have noticed since this global pandemic hit is that usually when we meet physically, we can interact with each other and communicate and talk. So you can please join the Discord and let's keep the communication up. And this Discord is actually pretty neat now because working with Azure, it's designed so you can have all the go-to information there. If there's outages, if there's new updates, if there's deprecations, etc. And the discussions are really interesting at the moment. So please join it and stay connected. Hopefully it will add value to you. This link will also be shared if not already shared. Then if we look at our next event, it's about Azure security with Stefan Schörling, and it's next Tuesday already. So sign up on the meetup, join the Discord, stay updated. It will also be posted on Foo Café. So there's another event coming. And then we just want to share some hackathon information here. So there is a really nice Hack the Climate hackathon that's going to run between the 22nd and 26th of March. It's all the challenges are real life scenarios by non-profit organizations. There's a big team of judges and mentors, etc., involved. So if you join, if you have an idea, if you want to build something, join a team or anything, go to this link and sign up and stay updated on it. It's pretty soon, 22nd of March. So yeah, it's a cool opportunity. Of course, there will be prizes for winning submissions. So yes, and that's actually all that I wanted to say. And with that, I want to hand it over to you, Peter, and I'll let you to do your introduction.
Yeah, thank you, Michael, and thank you for having me here, Azure Skåne. And I'll share my screen here to get started. Let's do this and that, and before we start, I know this is live and it might be a few seconds or up to a minute delay, but please write any questions you have in the chat, and I think Michael or Johan will be able to moderate those and pass them on to me. And if we're still on the same subject, I'll try to answer them, or otherwise we can try to collect them at the end if there is time for that. But please have questions, and please stop me if there is something you need me to dig deeper into. So I'll get back to exactly who I am, but first, let's have a look here. So myself, I am reading this, or what you would say, comic, or this thing called Xkcd from time to time. I wouldn't say I read everything, but most of the people I follow on Twitter also follow this one, so they usually show up, and they talk about specific cases that's relevant for the IT industry, I would say. For example, you have this. You might have seen that already. Are you coming to bed? I can't support it, but someone is wrong on the internet. And there are a lot of them that are really, really great. But a couple of years ago, I think it was roughly a year ago, I read this one. Let's jump to it. Let's skip that one. But this one, let's take a minute for you to read this one. And as it states at the bottom, in computer science, it can be hard to explain the difference between an easy task and the virtual impossible. And I would say, working as an IT consultant, this is exactly how it can be in the day-to-day life, that someone says, hey, please, can you do this? Sure, that will be done by tomorrow. Oh, and by the way, can't you also add this button? Oh, yeah, that will probably take half a year to accomplish, because it might differ so much in scope. But this one, it states that to check whether or not an image contains a bird, she will need a research team and 5 years to do this. And this was released in September 2014. So that's roughly 6 years ago now, or soon, I guess it's 7 years ago. But I thought, is it really 5 years of work to find out whether or not an image contains a bird? And so I started by looking at what would it cost by doing it with a research team in 5 years. So let's just do a quick calculation here. A researcher has an average wage of $77,000 a year in the US. And to make a team that is of some sort of size, you need at least 3 of them. So that's $232,000. And in 5 years, that would add up to the Swedish amount of 11.5 million kroner. That's quite a lot of money, and I'd say there are few companies that would spend such a huge amount of money on finding out whether or not an image contains a bird. But I thought we need to be able to do this much, much cheaper and with much less effort, using the AI that is available out there. So let me introduce to you the service called birdornot.net. So I will make a quick demo of that live. It's a site available on the internet, so you can try it out yourself. And I have a few samples here. We can start with that. So if we look at a hummingbird, for example, we give it an image to the Wikipedia page of a hummingbird. It will detect that, yes, there is a bird in the picture. It's actually a hummingbird. It's within this boundary in the box, and it's 90%, or yeah, the confidence for this is 90% that it's a bird and 67% that it's a hummingbird. We can also look at, if you wonder whether or not a penguin is a bird, yeah, it's classified as a bird. We can also look at something that is not a bird, like an alligator, for example. And yeah, this is not a bird. Instead, it identified it as an African crocodile by 84%. And used to, those are like my pre-built cases. So let's take something new. Let's take this, for example. I'll take the image here. I'll paste that URL to that image, and so this identified as a bird, but couldn't actually tell what kind of group the bird belonged to. But it's very sure that this is a bird. And I made this service or this site roughly a year ago or 2 years ago, maybe. I sent it to my colleagues, and the CEO of our company immediately came back and said, I supplied this. I supplied an image of Larry Bird, and it didn't say it was a bird. The service is wrong. So then I actually, I think if we try this one, let's try it now. So now it actually also I've learned it to identify Larry Bird, or it's actually looking at the celebrities found in the picture, and if the celebrities name the bird, it identifies and classifies this as a bird. But I'll get back to the presentation and explain to you why I built this kind of ridiculous site. But I wanted to show that using modern services and using pre-built AI, when that fits your use case, you can do things like this very, very fast. So I actually hadn't looked at the specific details of these APIs before I started with the site. So from going from that to building this site, buying the domain name, publishing it to an Azure App Service, it took roughly 5 hours. And I would say CSS was probably 3 of those hours to get those boxes a bit tilted and things like that. And the API call cost me about 0.058 kroner per image analyzed. So that's about the cost. Compare that to the 11.5 million kroner we estimated it to cost according to this comic. And what I want to show you, I always want to set the stage that during this session, I will show you quite a lot of services, quite a lot of AI built as services that we as developers and we as companies or consultants or whatever we are can consume to get to the business value much, much faster. And it's not always that it will fit our needs by 100%, but it will get you started really quickly, and it will get you very far with very little money and very little effort. And there are of course disadvantages, but we can look at those later. But during this session, we will look at a lot of different services. I'll try to inspire you to see what is available out there, what can we use it for, and bear in mind that I would say all of these services, if you're a developer, if you have experiences calling REST APIs, you can be up and running in a few hours with a service like this. So this is me. My name is Peter Örneholm. I work as an IT consultant at the company called Active Solution. We are a consultancy company in Stockholm, working a lot with Azure since the very beginning of Azure. We are working a lot with these kind of services. We know that we are great developers. We love C#, we love TypeScript, and we love all those kind of languages. But we also know that we deliver the most amount of business value when we use things that other companies like Microsoft have provided for us, and when those fits our needs. And my name, I'm also the MVP. As I know, the first and only AI MVP in Sweden so far. And that's mostly based on my work with Cognitive Services. I run the Azure Stockholm meetup. We have done a few online events since the beginning of this pandemic. And yeah, this is me, and I'd like to take you on this tour. So let's dive into it. And as I said, we are a company. Yeah, I didn't mention that maybe, but we are a company that have roughly 45 employees, and we know that we can't have all of our workforce work on the fundamentals of AI. And if we look at the news that was released not too long ago, Amazon said that they have over 10,000 employees working on Alexa, the kind of smart assistant. And I know, of course, this is not just AI people, this is not just developers, it's probably marketing and support and all of that, but it takes a huge amount of people to get something that complex to work if you build it from the bottom up. And not many companies that we work with even have 10,000 employees. So it's kind of, when we are doing things with AI, when doing things with this, we need to have another focus. And yeah, and by saying that, there are a lot of different definitions on AI and machine learning. We'll skip the exact definition, but I just wanted to plot it out on a scale. So if you look at a scale, I would say that on one of the ends, we have kind of the very theoretical parts of machine learning and AI, where we have the kind of the more of the university part, or the kind of making new algorithms and all that kind of stuff. Not very business focused, not very business oriented, much more mathematics and things like that. On the other hand, we have the consumer version of machine learning and AI that people like my parents and my family and me myself are consuming, maybe not knowing that it's AI under hood that's kind of powering it, like Amazon Alexa or Google Home or Siri or Cortana and things like that. Or maybe the spelling thing in Word or whatever that's on that side. You're consuming it, maybe not knowing that it's AI that is powering it. And then we have things from Microsoft like machinelearning.net that sits somewhere in between here, probably more to the right side, where you can create your own machine learning models and consume them based on data and your own data set. And the key here is that with ML.net, you mostly need your own data set. So if you want to train it to identify a bird, you either need to find a pre-trained model to start with, or you need to find a lot of images on birds. And you don't do that within 5 hours. So to solve that thing, Microsoft have created Azure Cognitive Services that sits somewhere in between here, that it's easy to consume, it's easy to get started with, because they have pre-trained a lot of models based on their own data or data that they have collected. And Cognitive Services isn't just something new that they came up with and created. Cognitive Services is based on their own, on Microsoft's knowledge and prior services, so to say. Because in Windows 10 they need AI, in Xbox they need AI, in Bing they need AI to, for example, we take Bing as an example. If you search for bird in Bing, you want to find images of birds, so therefore Bing needs to understand what is in this picture. Is there a bird? Is there an alligator? Is there a penguin, for example? And Office needs spelling things, and Office needs to understand text to be able to autocomplete things and stuff like that. So Microsoft themselves have the need to use AI like this. And because Microsoft works a lot with partners, and a huge amount of the money for Microsoft is companies like us that are building things on the Microsoft platform, and therefore they have made products out of these features, so that we can consume these services and these functions as services. And Cognitive Services itself is kind of split into 4 major categories. We have visual, identifying, for example, things in videos, things in images, identifying handwritten text in images and things like that. We have language to extract information from text, to extract key entities and things like that. make summarizations. We have speech to be able to take text and make it into a speech, or take speech to make that into text. And we have decision, which can take a large amount of numeric data or time-based data and find anomalies, find if you have a forum or a chat function, it can identify and moderate that thing so that it's kind of no adult content is being posted, for example. And this is then split into a lot of services. So these are the categories, and then you have the services. And I will not be able to touch on all of them, but they follow the same concept. So if you have started using cognitive services, you will very much be familiar with the concept of using them. And these services are by default hosted in Azure, and you will always find the latest version in Azure. And they are accessed by HTTP APIs. So from whatever you can call HTTP and the internet, you can access these services. So independent of language, as long as you can call the HTTP API. But there are SDKs available for most kind of the major languages out there. So if you are running C# or .NET or JavaScript or Python or whatever, you don't need to kind of read up on the HTTP API spec for the services. You could probably use some IntelliSense for that specific thing. And all of these services, the vision, speech, decision, and so on, they are under hood powered by AI, machine learning, and kind of old school if statements and things like that. And it doesn't really matter exactly, from my point of view at least, it doesn't really matter exactly what algorithm is being used or what model they're using at the moment. And what matters if it solves my my use case and if it fits my needs. And things have changed since these were launched, because now you're not required to use the services that are hosted in Azure, because a lot of these services are also available as Docker containers, so you can run them in your own cluster or in on-prem and so on. But it's worth pointing out that it's not for offline scenarios, because you are still billed by the public cloud. You're still billed by public Azure. So the containers needs internet access to be able to kind of ping back and say your consumption, because these things do cost money. Most of them you're paying by usage. You're paying by the image being analyzed, or paying by the amount of text you translate, or paying by the seconds of video you are analyzing, for example. And I know that a lot of you are probably technical people and maybe have developer backgrounds. So I will show you a few lines of code here, but I have so many demos that I'd like to show you, so we won't be able to dig into the code on all of them. But I will just show you the concept on how this works, so you get kind of the point. And basically all of the demos I'll be showing you are open sourced on my GitHub, and there will be a link at the end, so you can dig into the code of them and see how they work and so on. But the concept is like this. You create the service in Azure. You say, I want to create a text analytics resource or a computer vision resource and so on. So that, and then you get a key. So that's basically keeping track of your usage, and that's where and how you're being billed. And for the bird or not site, this is the example, and kind of if you boil it down to the very most fundamental lines of code, then we say, okay, I want to analyze this image. We use our computer vision client. We tell it to analyze an image. We give it the URL of that image, and we say, what kind of features in the image do we want to look for? And in my case, looking for a bird, for example, that's looking for some objects in the picture. Then we get back the results, and then we see, are there any objects that is called bird? And yeah, there seems to be that in this case, for example. And then we write the answer. So these are the very, very few lines that kind of the core part of that site. And it's, I just want to show that it's quite easy. And it's the same thing with if you want to translate text, if you want to analyze text and so on. You don't need to care that much about the actual training of the models. So let's dig into some demos. We've already seen the bird demo. By the way, are there any questions so far in the chat, or should I move along?
No, we actually have a question.
Yeah.
So, question is, how production safe are these services? And it goes on. I mean, these cloud AI services depend on the training data, and with new data, you can start to trick them. Do you need to have a lot of error handling on these services?
So the import, I think I get the question, and I would say they are very much production ready. And the thing here is that in a lot of ways with AI and machine learning, you want the model to continuously improve and learn. But when you're using these services, Microsoft is not using your data to evolve the model, because that could mean that someone could kind of say that, oh, this is not a bird, or they could kind of fool it or make the model dumb. So they're not training the model on customer data, because that would be, yeah, that wouldn't work out. Some of these services, which I will show you later, allows you to train your own kind of model on top of the base model, but that's just for your own usage, so to say. So that then you really need to think about what data you are training it on to make sure that you get a kind of a diverse model that handles the cases you need to, and so on. But I would very much say that it is production ready, but of course you should verify that it handles your scenarios, that it is diverse for the scenarios you want to use it for, and so on. I'm not totally sure if that answered the question, but some thoughts about being production ready at least.
Yes, thank you. Let's see if there's a follow-up eventually.
Yeah. So let's continue a bit with the computer vision parts, and I'll just show you Azure. So some of you might...
Actually, there is a question before you continue.
Yeah.
So the question is, you're not training the service on your data.
Yeah. So I'll get back to more details later, which I will show you and explain. But as I said, the base models in these services, they are trained on the data Microsoft provides. So for example, identifying a bird, I didn't have to supply 100,000 of images of birds to teach it how a bird looks like. Instead, I was able to use the base model to learn and use that to see, is this a bird or is it not a bird? But then there might be specific birds that it can't identify, or we will actually look at an example quite soon where it can identify this is a car, or this is a vehicle, or this is a boat, for example. But if you want to teach it about this is a Volvo, this is a Tesla, this is a Porsche, this is a Lamborghini, for example, the base model doesn't know that. But then we can train our own car model on top of the base models. We can train kind of car manufacturer model on top of the base model. And that data and that model you train there, that will only be in the scope of your tenant within your project. So no one else will be able to affect your model, and you won't be able to affect someone else's model. But you will still be able to train for specific scenarios. And I actually have a demo quite soon on that. So that leads us in on the cognitive services part. Let me bring up my little thing here. So if you have been on the kind of the product page for Azure Cognitive Services, you might have seen that there are a few demos that you can try out. But these demos are very limited in usage, and they have actually taken away a few functions that was there a couple of years ago. So I decided to create my own open source project called Cognitive Workbench. And it's available as a site, and it's available as a Docker image if you want to run it locally, and the source code is available on GitHub. But Cognitive Services, the goal of this one is to be a very kind of low-level visualization of the Cognitive Services APIs. So that because when you analyze an image, what you get back is a huge amount of JSON with a lot of coordinates and a lot of kind of tags and things like that. And it's very hard to be able to get an overview of that data without visualizing it. So I've created a website called Cognitive Workbench, where you supply your own key and basically your own credentials for the service. And then you can hand it an image that we will analyze. So let's take this image to begin with. This is an image I took in Umeå when I was there and presenting this session some time ago. And this is based on the result we get back. And you can actually, in this website, you can see the raw result that we get back, and it's a lot of JSON. But I've also parsed it to make it a little bit easier to see them. And to begin with, the Cognitive Services Computer Vision API gives back, let me see, a description of the image. So this description in this case is a truck is parked in front of a building. And the confidence for this one is 93%. We also get a few tags. There is a building, we are outdoor, there's a truck, car. I'm not sure about sitting. Maybe there are people sitting in the background, not sure. And so on. And we also get some tags with confidence that there is sky, outdoor, and so on. Let's scroll down a bit. And this is interesting. As I mentioned before, when we identified birds, a bird is an object. The same thing here, it can identify the van in this case. And the van is part of the category car, which is part of the category land vehicle, which is part of the category vehicle. And we get confidence scores for each of these kind of steps in the hierarchy. We also get the coordinates for this one. So we know that where in the picture is this available and so on. And this could be used, of course, if you're building a website for selling like eBay or Tradera or Blocket, as we have here in Sweden. Maybe someone uploads a picture where there's a lot of spaces around, and we know that, yeah, we are looking for the car in the picture, or we are looking for this one. So when you make the thumbnail, you can actually make that a smart thing to actually try to find the most relevant object and make the thumbnail out of that, and things like that. So you can use the coordinate and information here to find that. And also, if I follow a few Instagram accounts where with kind of funny pictures from Blocket, and people who are like, oh, I'm selling my car, and then they upload a picture of their granddaughter or grandson, and it, probably because they just choose the wrong picture in their phone. And you could use services like this to say, okay, it looks like you're telling me that you're selling a car, but in the picture uploaded, I can't find a car. Are you really sure that this is the right picture? And things like that. And because these are not and will not be 100% correct, you should probably never force or kind of disallow someone to do that upload, but you could guide them along the way. I actually found a little nice picture of this. This is probably not the Microsoft algorithm, but there was a news article yesterday about one of the computer vision's algorithms out there. And if you have an Apple and then write iPod on it, it goes from, yeah, this is not an iPod, into actually, yeah, this is 99.7% sure this is an iPod. So this is OpenAI's vision system. I'm not sure how we can probably try. Let's try this. Let's try this. Copy image link and see what computer vision would say. Let's see if it does something. Invalid image format. Okay, it doesn't support that format. Sorry. But there are ways to trick these, so you should kind of not rely on them 100%, but they could guide you along the way. But let's move on. Let's take another picture. Let's take this. This is the Stockholm City Hall, and let's analyze that one. And I just want to show you here that to begin with, this is a large clock tower next to a body of water with Stockholm City Hall in the background. Yeah, now the clock tower is part of the Stockholm City Hall, but yeah, it's quite good actually. And this one actually, Stockholm City Hall is famous enough to be part of the landmark category. So it has identified that this is the Stockholm City Hall as a kind of structured landmark within this picture. And speaking of that, there are landmarks, celebrities, and faces. And let's take this is the Swedish singer Tove Styrke, and she is famous enough to be in the celebrities category. So let's take that. So if we go down, we have celebrities, Tove Styrke, and she is within this picture. And I think my gut feeling is that the celebrity and landmark identification is trained on Wikipedia data and Wikipedia images. So it's kind of, if you make it to Wikipedia, you will probably make it into these categories as well. And here we have faces. Let's take another picture that is more relevant for the faces category. I think we could have this one. It's an image of me. So this is an image I uploaded to Instagram after, this was before I had 2 kids and and we didn't have a pandemic, so I was able to go around and talk about Azure. So the funny thing here is that before I show you the results, the funny thing here is that the leftmost image is from, I think it was the Tuesday when I was in Norway speaking about Azure security. Then on Wednesday, I went to Denmark speaking about cognitive services. And on Thursday, I went back to Sweden speaking of Azure App Service. So 3 different subjects, 3 different cities, 3 different days. And if you ever wondered what speaking so much and traveling so much makes to your age, we can ask Cognitive Services. Let's go down here. So Tuesday, 28 years old, Wednesday, 30 years old, and Thursday years old. So getting more tired and more tired by every day, I think. But as you can see, it has identified that these are my faces, or these are faces in the picture. I have glasses. It's not sunglasses. In this picture, it's the same glasses, but here it got it right. And we get some kind of visual guess on how old I am. Let's see what we have more. Yeah, we have the OCR API, but let's take a more interesting picture. I can't remember how good it is at identifying this. Let's. This is a handwritten letter from my grandmother, and I know it's becoming better and better at Swedish. No, it's kind of it's still too gnarly for it, or too hard for it to identify it in any good manner. But as we can see at the bottom, at least, we have some machine printed text where it's quite good at identifying and finding these texts. So we can also make a good OCR out of quite a lot of documents. And I've seen especially kind of old handwritten, or if it's not too complicated, it's really good at actually getting this. And very recently they actually announced the news that you can tell the OCR API to identify the natural reading order, while previously it kind of only it looked at the document and then just gave you all of the words from left to right, even if they were like in different columns and so on. But now it will try to figure out what is the natural reading order of this of these text. Yeah, let's see. Let's move on to custom vision. As I got a question about, can we train our own model? And let's see where I have that. I'll go to the custom vision. So the custom vision service is basically taking computer vision as the fundament or the base, and then train your own model on top of that. And the idea here is, and I used to mention, the custom vision portal is built kind of it's very consumer friendly. So it's a Microsoft portal built on top of the custom vision APIs, which makes it really easy to train your own model. So it's really easy to get started. And I have a few colleagues that are actually running some kind of a code. Before the pandemic, they were running code nights with kids and taught them how to use this portal to train their own AI model. So it's very, very user-friendly, and it's easy to get started with if you want to train your own computer vision-based AI model. But what I wanted to do was, I'll show you the picture. A couple of years ago, I think it was a year ago or something, we were playing Bull, me and a couple of friends. And if you play that, you know that a lot of times you need to kind of see who is closest to the jack, which this little red thing is called. Is it my team or is it your team? And of course you can take this measuring thing and figure out who is the closest. But I thought, can't we make an app out of this? And there were a few apps, but then in those apps you actually had to make a square around where are your where are the balls from your team, and where are my team, and where is the jack? And then you needed to kind of draw lines around them, and then it would figure out how many pixels are there between these and who is the closest. But I thought, can't we identify these automatically? So my first thought was, okay, maybe computer vision can identify these ones. So I gave it the URL of such image. I tried to upload it, analyzed it. But if you look at the objects thing here, there are no objects available. So it didn't find anything of these. It didn't even find my shoes. It didn't find these, the objects that I was looking for. But then we have custom vision to the rescue. So if we go to the portal here, custom vision portal, I've created a Bull project, and I've uploaded roughly 20 images of people playing Bull. And by doing so, maybe I can find another picture just to show you how easy this is. Bull. So you supply it a lot of images. So let's take this one as well. I don't think that was in the data set before. So I will upload another picture here, add the images. We upload the picture. And then we train it. So then we can start, it has identified kind of unidentified objects in the picture. Then we can say this is a bull, this is a bull, this is the jack, this is a bull, this is the bull, this is the bull, and so on. And I even think now it did train that thing. Let's take another picture. I even think nowadays there is a quite new feature where you can get suggestions. So when you have started to tag these, it will learn that, okay, Peter is actually looking for bull and the jack. And let's see. And it will be able to suggest for you. How is it doing? Yeah, so now it suggested, okay, I think this might be a bull, I think this might be a bull, and I think this might be the jack. Can you confirm this for me? Yes. And I confirm it, and then it will train on that image as well. And we will have to make a quick training. So now we have supplied more data. We have supplied 2 more images telling it how to identify the bull and how to identify the jack. And we have trained this model. And for demo scenarios, we can do the quick training. It should maximum take a minute or so. And so this is, and the minimum amount of pictures it requires, I think, is 15. But the more images from kind of the more with the more backgrounds you have, with the more maybe some small images, some large images, some with bad lighting, some with good lighting, and things like that, the better accuracy you will have in your final model. yeah, I'll try to test it on the first iteration instead. So if I take this image that it didn't identify with the out-of-the-box model and run it here, so now it has identified a lot of things, and it even identified my shoes as bulls, but those had quite low confidence score. So if we upper the threshold here to roughly 80%, we do get a very good representation. So all of the bulls were identified and the jack was identified. So this you can use to train it on your own data set, whether if it's bulls and jacks, or if it's Volvos or Lamborghinis, or yeah, use your imagination. So this can be used and then be packaged as your model, and you can actually deploy this model to a phone or deploy this offline. So these is one of the exceptions where you can deploy the model to run offline, because the business model from Microsoft is to charge you for training the model in the cloud. So it spins up a lot of GPUs and trains the model and figures the model out. But then once it's done, you can have that model and run that offline. So that differs a bit from the other cognitive services models. So before I move on, Michael, are there any more questions?
Yeah, so there was one follow-up, but I think you answered it. The question was, you're limited to their categories and tags when you train it. But
no, so let's just you're not limited to them. So if we go here to let's start over. So we can create a new project. Let's call that let's go on test. Let's do object detection. Yeah, I want to be able to dive into all of the details, but depending on your scenario, there are things you can tweak here to get a better base model. But let's run that one. And then let's say if we were to identify, let's say we're identify Darth or Star Wars Lego, for example. Lego, we're going to do mini fix. So here we could, let's just download one or two of these ones. I won't train the model, but just show you how you could tag them and start training it. So let's download that one and that one. And there's probably another one. So by doing so, then we can add images, and then we'll use these images, upload those. So now, if I were to run get suggested, it won't be able to suggest anything to me, because I haven't started to I haven't tagged anything in my custom model. Instead, I will have to start creating my tags that is relevant. And I actually rewatched Star Wars quite recently, but I have to admit that I'm not too confident on who is who here. But let's say that this is, and I know people will be mad at me probably. And this isn't this maybe? Yeah. So let's say this is Luke as well. Let's take another picture. This is at least Yoda, and then this is Han Solo. And I can't spell the name of those. Yep, isn't this
Princess Leia?
Yeah, there she is. So as you can see, it kind of identifies that I think there is a box here. But if you have your custom box, you can always yeah, but this is a group of people, or this person is actually two persons tall. So you can always draw your own box, but it tries to identify the boxes itself. So let's do Leia. And so on. So once that is done, and if I go back here, then let's say that, yeah, this is also Yoda, by the way. So let's try to do that. And now I'll just get autocomplete suggestions on tags I've already used. So it's very much up to you to create those tags. And that data will be, it's your data, it will not affect, it will not train the Microsoft models, it will not be shared with any other customers and so on. So it's up to you what you define there. But I used it to train for Bull and for Jax, and I used it in another demo to train for car models. Yeah, let's move on, and I hope that made some clarification that you can get very far with the base model to identify this is a car, this is a bird, this is that kind of thing. And in some scenarios, it kind of knows the subcategories. It knows that this is a land vehicle. It knows, but it doesn't know about Volvo. But it knows about hummingbirds, and it knows about alligators. But sometimes you get into your very specific domain, your specific scenario, and you want to train it on very niched categories, for example. Then this service can be very good as a complement to the base computer vision service. Let's move on. We have another service very close, I would say, to computer vision that is called face. And the computer vision contains this base model for face, knowing like this is a person aged 34 in this picture, or there's a person with the visual age 28 in this picture. But if we want to know specifically the specific details about face, there is another service called face service. So let's dig into that.
There's actually a question that kind of, I think you will go into this. And the question is, how about other aspects of the picture? What category of things it in, like not faces, but aspects, what they're facing, looking, or how glad they seem.
Yeah.
I think you're coming to that now.
So very good question. Let's dive into that. So let's bring that up. Here's the product page for face in the Cognitive Services. And it will show you some of the aspects of this. You can use this demo if you'd like, but I've also built my own. So if you supply an image here, let's take, if you're from Sweden, you might know our king, and he's a public person. So and he usually shows. Let's see, like that. Sorry. So here it has identified a face of our Swedish king, and that gives us quite a lot of details. For example, he is 100% happy. No anger, no contempt, and yeah, you can't look more happy than the king here. And at the time, he looked like 67 years old. He has a little beard and some mustache. Doesn't wear eye makeup or lip makeup. And if we zoom in here a bit, we also get, you can look at the raw data, but we get a lot of coordinates on key points in his face, like where is the lip, where is the top of his nose, where is the left part of his eye, and things like that. So I've seen demos online where people take this data and basically add a mask on you. You know, these snapshot filters and things like that. They are probably based on some other technique, but you could use this API to do the same thing. And in that case, is to mention, I mentioned previously about running these services in Docker containers, and it's still a kind of online scenario where you need access to the internet for it to periodically kind of send back how much should I build. But if you need low latency, so for example, if you were to build kind of what would you say, a real-time scenario where you would modify the picture, maybe I think I've seen another demo where people adds emojis to your face that kind of follows along. You don't want the latency between your computer and the data center in West Europe, for example, because that would add a lot of lag. But in that case, you could run your container locally in your own data center. If this is for a business scenario, you could run it on your own computers or in your own data center to get really low latency for those services. Maybe it's a webcam scenario where you want to identify things that shows up in the image, and you want to do that 10 times a second or so. But as you can see here, we get quite a lot of data in the raw JSON data here. We have all of the pupil right, the nose tip, the mouth left, and so on, and a lot of different landmarks in the face. We have that face. Let's take another image. Let's take this one and analyze it. And he is angry. He looks like much younger. No smile. He has anger, and he is surprised. So we get that kind of thing. And he also wears glasses with a confidence of 94%. There's some CSS issues here, but so we can't see it. But there is also she is also identified within this picture. And there, in addition to this, there is also service for like, is this the same person? So you give it 2 images of a person. I'm not sure if this is available here. No, it's, let's see, face verification. Yeah, we have it here. So here you give it. Let's try it with the king here. Let's say, let's take that image, submit, and let's take that image. We were unable to find. Haven't seen that before. Yeah, now it's correct. So now it says that the confidence that this is the same person is 89%. And I think one of the use cases I've seen for this is Uber, using it for when the Uber driver kind of starts his or her day in the car. You need to identify with a fresh picture of your face, and it will confirm that this is the same person that once created the account, so that you as a passenger should know that the one that the app states is the driver is actually the driver. And I think Uber is kind of a featured, Uber is one of the featured cases here. So you can learn more about that. And there is also the perceived emotion recognition. That I think I already showed you that one, where you can see that. I'm not sure if there is so much more to say about that. Yeah, actually, I created another. Speaking of creating ridiculous services, I created a site called cogbox.net. And yeah, so this one, now you see my room without all of the blur. So this site uses the face or the age detection thing in the face API. And it tries to identify how old I am. And then it uses the Spotify APIs to kind of search for albums from the year it thinks I was born. And then it searched for the kind of the best album that year. Or I'm not sure how Spotify kind of does it, but there is an API saying I want the most popular album from this year, and it will give you a song from that album and play it. So let's see if it's kind of. And I'm actually, I'm turning 30 in a month. So let's see what it says now. Or actually, sorry, I need to share my audio. I don't think I do that at the moment. Include system audio. Let's do like this. Include system audio. Screen 2.
Peter, while you do that, I could chip in here and tell the people in the YouTube chat that we have issues posting comments and links, so we cannot interact with you. I have no idea why, and I even tried with different computers. So,
okay.
But at the end of this session, we will have some links at least, and I will show them again on the screen for all the ones in the chat.
Good. So now I think I share my system audio as well, so you'll be able to hear this this app as it should be. Let's see. Let's try it now.
You look like 29 years old. I will play Down in a Hole by Alice in Chains. A great album from 1992.
So it's let's doesn't play it too long because that will remove it from YouTube because of copyright issues, I guess.
It's almost rigged.
Yeah, I was quite happy to see it turning into 929 because I've been standing on stage in front of 200 people and they told me I was 14 years old, and so it's it's getting better and better, or I'm maybe just getting older and older. I'm not sure. That's one of the things you can do, and this site is also available on GitHub, and you can look at all the source code, and you can try it out yourself if you'd like to. But I found out that not too many people are tweeting about it, but the ones who have done that, they actually tweeted when it said they looked younger than they actually were. So maybe I should add some kind of subtract 5 years to get it more viral, I'm sure. But let's close this one again and move on. Time is running. Let's. I just want to mention a few things here. I'll do a few shorter demos on. One cool service. Let's see if I have that handy here. Nope. Let's do the, I can use the mention video indexer. That's also one of those video indexer. One of those services that has a really cool portal that is really user friendly. You can log in with your personal account or a Google account and so on. So it's people that want to test it can try it out. This one, I would say, builds on top of a lot of APIs. So you're able to index a video, kind of get a transcription of what is being said, automatic subtitles.
Yes, but if there's a lot of people,
you get the kind of insights. When are people talking about? When am I talking about different subjects? When do I have joy? When do I have fear? And so on. So if you're in the media industry, this could be really good to make automatic subtitles or kind of make videos indexable and searchable. Let's go to one last thing in that category is form. I'll just show you it quickly if I have the. Let's bring this up. See if I have. Now that demo have started failing, but I want to mention the form. I can show you.
While you bring that up, we have another question.
Yeah.
Maybe we can grab that. What format are the models then once you create it and download them? What language and API? What can you mention about that?
Yeah. So it was so long ago. Let's see what. Custom vision model download. I think you can download them. So it supports the following exports: TensorFlow for Android, Core ML for iOS 11. I'm not sure how to pronounce this. ONNX for Windows ML. And you can actually download it as a pre-built Docker container as well. So it supports multiple download formats. And I think this is the format you should choose if you want to consume it from ml.net, for example. Let's get into, so the demo I wanted to show you, or just briefly mention at least, is the form recognizer. It's not kind of, maybe not as cool as the other demos, but we have seen a lot of business interest in this one because it allows you to train it to be able to understand PDF documents, for example, or images or PDF documents and forms, basically, where you say that, okay, this is an invoice and this is on my invoices it looks like this. This is for the from address, this is the to address, or this is a specific business document. Let's see if we have some Yeah, we have a specific business document here. And then you provide it with kind of 5, 10, 15 samples of such document and tell it that, okay, within this box, you will find the recipient's, lender's TIN, and this is the payer's borrower's name, and so on. And even if if the documents are scanned, and some of them might be skewed, some might be from a bad mobile camera, some might be handwritten, some are using machine printed text, it will be able to grab all of that data and give it to you in a structured way. And that makes it really cool for companies that want to kind of automatically extract information from unstructured data. And that's really cool. We also have, speaking of text, I built a few demos around text. So let's go back to the where do we have it here? The cognitive workbench. So if you have, and basically the only input to this API is some text. So you give it text and it will analyze that for you. So let's take some, I'll take some Swedish news here. Let's take this. Are there any text available? Yeah, I'll just grab this complete text here. Paste it into here. And it understands Swedish, so now it has been able to begin with, identify that the language of this text is Swedish, and the confidence is 100%. The sentiment, basically, is it written in a positive or negative way, is roughly somewhere there in between. But now we get to the really cool parts, and this is the recognized entities extraction, I think it's called. And that is that it can identify, out of all of these things, it can identify structured and typed entities. So it knows that within the text, Rasmus Wengberg is being mentioned. And I think, let's see if we can see where that is. Oh, we didn't get that out. Or maybe we do get it down here. Let's see. Yeah, so here we got the even more details. So we see that Rasmus Wengberg is mentioned 3 times within the text, and I haven't visualized this, but we can see that it's at the 385th character, and the length is 15. So we can theoretically know exactly where in the text he is being mentioned. And then we have Umeå, which is identified as a location. We have Götaland is a location, and so on. Sara Bifors is a person, she's mentioned once. We have Stockholm, which is a location, and so on. So it's able to identify, and it does this not by looking at kind of that Sara might be a celebrity. It's rather looking at the context and figuring out, okay, because the text is written in this way, this is probably a person, this is probably a location, and so on. And this could be used, of course, to make a better, if you have a lot of text, you could index that, you can make it searchable. Depending on this one, you could extract the information to tag documents with these kind of entities. We also have key phrases extraction. So these are kind of the key phrases for this article. And that, I would say, it's up and down. Some of these are irrelevant as key phrases, some are really good, and it might be missing out on a few. But the named entity extraction, I would say, is very spot on. And if we combine a lot of these services, or yeah, let's mention one last here. And I don't have a custom built demo in the Cognitive Workbench, but let's go to speech. And even if this is in English, because like every AI is really, really good in English, but I will take, of course, we have speech to text. So we could, if we have, let me try this. Hello there, how are you doing? Are you having a good day? looks like that, and it looks like Cognitive Services handles this really well. And as you might have seen, while I was speaking, it kind of added and went back and added context and kind of figured out, okay, now I'm done with this sentence and so on. So it's really, really good actually at identifying speech to text, and it even supports Swedish. Let's try that. Hej där, hur mår du idag? Jag föreläser på Azure Skåne. And yeah, this didn't turn into Azure Skåne, but rather aktionen. And there are ways of with using custom speech. You can actually train it and learn, teach it about specific things that are specific to your domain, for example. But this is the speech to text, and yeah, it's worth knowing that you get in the raw API, you get access to kind of when did he or she say that word and so on, so that you could make automatic subtitles out of that. But we also have speech, text to speech, and the voices I'm about to show you, they are very new. I'm not sure exactly when they were released, but they are new voices based on a new model they have trained, the neural voices. We have Sophie, Hillevi, Mattias. They are the new ones, and Hedvig is the old one. So let's take that article. Let's use the same text. And let's make it speak.
Nästan 50 elever smittades på en vecka, som en stormvind. Publicerad idag 17:48. Flera regioner larmar om skolutbrott, och på flera håll.
And Matthias, can you just confirm that you hear what I hear?
Yes, we hear
Great.
beautiful Swedish.
So we'll take another voice.
Nästan 50 elever smittades på en vecka, som en storm.
Let's skip a few things here just to get down a bit.
Västra Götaland registrerade i förra veckan en...
And we also have the male voice.
Västra Götaland registrerade i förra veckan en ökning på 57%.
And if you compare that voice to the old one, which is not based on neural,
Västra Götaland registrerade i förra veckan en ökning på
I would say that the Hedvig is much more of a robotic voice. Even if it's a good voice, it's much more robotic. So I would say the Sophie and the Matthias, they are really, really good. And it's kind of, we're getting to the point where it will soon become really hard to distinguish between the AI voices and a real voice. But that makes it that I know that there was a discussion in media like last week regarding a really bad people who have kind of recorded books. I'm not sure what it's called in English, but they were really bad quality. And I think like it won't take long until everything will be read by these voices. And especially now that you have custom voice, you can actually train it on your own voice. So basically the author of the book could using Azure Services actually train their own AI model using their voice, read a few sentences, and it will learn about that voice, and then you could make it read the whole book with that model. And that is actually one of the services in Azure Cognitive Services. Even if it's general, available, and so on, you have to apply to get the keys, because you have to describe your scenario and make sure that you are not doing unethical things with it, that you're using it responsibly. Because you could, of course, with such service, create really, really bad services and imitate people that doesn't want to be imitated and so on. But with kind of saying these are great things, I've created a site. I haven't actually run any data in it for a while, but we have data from some time ago. What I did was, because Swedish Radio or Sveriges Radio, they have a publicly available API where you can get all of their news, all of their like recordings, all of their basically every data is available from Swedish Radio through the API, and you get access to the raw audio and things like that. So what I made was a little bot, and you can read more about it in the blog post I wrote. I can just quickly show you the architecture because it runs in Azure. So it fetches it fetches the news episode from Swedish Radio or Swedish Radio Ekot, stores them temporarily in blob storage, uses Azure Speech to Text to transcribe those news episodes. And because it supports both Swedish and English and other languages, I'm actually transcribing both the Arabic news and the Swedish news and English news and so on. Then it translates those into other languages. So if it finds a Swedish episode, it will translate that into English. And if it finds an English episode, it will translate that into Swedish and vice versa. And then it will enrich the data. So it will use text analytics to enrich the translated text, to find key phrases and so on. And then it will turn that into speech again and store the summarization of everything in Cosmos DB. And then the site we're looking at, that's kind of the front end for it. So it will list the episodes, make it searchable, and being able to read it. So my use case here is, let's say that you want to listen to Swedish news, but you're here for here on vacation, and you don't want to learn Swedish for a 2-week vacation in Sweden, but then you could be able to listen to the news that Swedish people listen to, automatically translated into English and read for you in English. So let's pick up a news episode here. Let's take these are from May, I think. I actually stopped that bot some time ago not to listen for more news, but let's open up the details on this episode. Come on. Let's take this one. Yeah, here we go. So this is the original audio.
Snart fritt fram att hälsa på äldre släktingar och vänner igen. Nu slopas besöksförbudet. Den biologiska mångfalden fortsätter att tunnas ut. Populationen...
So it's quite good at actually identifying, and I think they've actually tweaked the Swedish model since I did this transcription, so it might be even better. Then it's translated into English, and then I created an English version of it.
Soon free to visit older relatives and friends again. Now the restraining order is being lifted. The population of wild animals has been reduced by February.
So this is a fully automated flow of taking the live or kind of, it's kind of the live audio, but it's using the pre-recorded Swedish radio news, so to say, and turning them into English text so you can read that. And then it's also able to extract this information. So for example, we have the Swedish Public Health Agency, and then I made a filter so that you could filter all news episode that mentions the Swedish Public Health Agency and so on. I'm not sure why the site is running so slow now, but yeah, you get the point. But this site combines a lot of the different APIs in Azure, and I think I will try to round that off with that. Let's get back to my PowerPoint. I didn't have time to show you all of the demos, but a few of them are here. And I would say that when my demos a lot of them have focused on one service per demo, just to show you, okay, what is possible with the computer vision. We look at that in Bird or Not. What is possible with custom vision? We look at that with Bull. What is possible with face detection? We look at that in cognitive jukebox and so on. But like in a business scenario, it's most likely that you will combine a lot of these services into the product that you're building. Like for example, with radio text. I was using speech to text, text to speech, text analytics, translation, and there's also a thing called immersive reader under the hood. You can read more about that in the blog post. And that's what when it comes to kind of the business cases of it, it's usually kind of knowing you have maybe 40, 50 different services at your hand, and they solve specific use cases. and it's up to you to kind of combine them to solve the problems you have. And speaking of cognitive services, a quick thing. I just want to mention that when the cloud came, it basically went from us having to care about servers, cooling, etc. We had Azure, and now we can focus on the business value. So we don't have to focus on that our hard drives are running out of space and things like that. We are rather focusing on the business value, and then Azure is the enabler for us to do that. With cognitive services, we have AI as a service, I would say. Under the hood, it's AI and machine learning. Cognitive services wraps those, and we can focus on the business value to kind of get what we need out of the services and out of the AI and machine learning. It won't fit 100% of the cases today, of course. These solve specific cases, and if it doesn't fit your case, you might have to go more low level. But when it does fit your case, and when it is responsible to use it, please go ahead. And speaking of responsibility, there are a lot of things to think about here that we as developers, or we as companies that are using these services, needs to use them in a responsible way. Use them in a way that the people who are affected feels that, yeah, they feel comfortable in how we use their data. They feel comfortable that, for example, as I said, if you're uploading an image to when you're selling your car, it shouldn't kind of, no, I can't find a car in this image, you're not able to use this image. I would say that it could say, I can't see the car, maybe you can point it out to me, or maybe, but kind of try to guide the users rather than blocking them or so. And a lot of people are afraid that AI will take their jobs. I don't think it will take their jobs in the near future, because there are so much flaws and so much edge scenarios that we can't completely replace humans, but we can guide them, we can assist them, that the persons who are using the services we are building, they should feel more confident in the decisions they are taking. They should feel that they have a second or a third opinion from the AI, that, okay, the AI also, I did the verification, and the AI also with the confidence of 99% came up with the same result. Then I'm super confident on actually verifying this product and so on. And there are very good resources from Microsoft on responsible AI and kind of checklists and things like that you can think about when developing these services. Because there are a lot. The Pope did warn about face recognition, for example, and how that could be used. Speaking of teaching a model and a voice for voice, this wasn't using the Microsoft in any way. I don't think it was even released at that time. But there are people using these kind of fake voice to scam people. And the Datainspektionen, because of GDPR, they actually did one of the things towards a school that was using face recognition. Not that it wasn't compliant with GDPR, it was just that they based it on the wrong kind of category within GDPR and so on. There were things, but just to mention, you need to think about stuff, need to think about responsibility and the law perspective of this before moving on. And with that, so I think I ran out of time. Sorry for that. But with that, on this URL, it will take you to a GitHub gist with where I've tried to collect all of the kind of links to the demos, links to the source code, links to the Docker images, you name it. You could photo that QR code as well to get there. And with that said, let's leave that up while we look at if there are any more questions.
Yes, so there was one follow-up here, and I think it's something you showed way back. Could you add restrictions on interpretations, like the month field should never be bigger than 12? And I guess it's about you being able to configure the services.
Yeah, I'm not sure.
I don't recall which one it was during your demos, but
maybe it was the form recognizer. It might have been that one.
Yeah.
Where I'm not sure. I would say in a lot of these scenarios you don't have that kind of fine grade thing. So it's more that you say, if we take form recognizer as an example, you tell it that I want you to start learning that within this field. Let's see. within this field, you will find the outstanding mortgage. But there is actually in Form Recognizer, you have the ability to say, please look for a text, please look for a numeric value, or please look for a, I think they include like money. There might even be date. So that will kind of help it to, you can specify what to expect, and that will help it to extract the right information. If that was, if the question was regarding that. But in general, I would say there aren't that much configurability in this one. You would rather have, you will get the raw data out of the service, and then you will have to build code and build the service around that to handle such kind of validation yourself.
Yes, and we got it confirmed. It was for the form interpretations.
Oh, great. Yeah, any more questions?
There's no more questions here, but it was really, really nice to see all the demos and all the functionality, and you really put it in a good picture here, like how, let's say, easy it is to actually build something really sophisticated, and not having to do the bulk of the work. You just call certain APIs, etc. here. But
and I would like to, I can mention we have just started working on this in a few business cases, so I'll probably have a demo for next time I'm running this one. But there is a service called Metrics Advisor, because a lot of the demos I showed you today was kind of connected to vision and so on, I would say. But this one is a really cool service building upon kind of time-based metric data, and it allows you to do kind of root cause analysis and so on, and find anomalies with your data. And this is very, very close to what businesses usually like. So this is a cool service that we are working with to use. And it's I don't have any fancy demo on that one. I had a demo. I think it's broken now, but I had a demo where I analyzed my heart rate during a session actually. And it found anomalies when my computer broke down. Yeah, it was long story short, Tech Days 2019, room was packed, and my computer, the T key, I think it was, on my computer got stuck like 5 minutes before the session was about to start. I think it was 200 people in the audience, and I couldn't do anything. I just had to kind of kill my computer, boot it up, and I basically 50 seconds before my session was about to start, my computer worked again. And I extracted the heart rate data from my Apple Watch, and the AI anomaly detection found a quite good anomaly at that point. Let's see, I might even have a picture of it. No, I don't have that. So it's let's see, Apple Health data, images. No, I don't have it available here. But it's there are of course a bunch of other services and so on, and feel free to. I'm not sure if I actually showed you my social media, but on Instagram and on Twitter, where I do post Azure and work-related stuff, you can find me at Peter Örneholm. Feel free to add me there, or follow me there, or add me at LinkedIn. If you have any questions, you could drop an email or ping me at Twitter or Instagram or wherever you feel most comfortable. From time to time, when I've made projects like these, I tend to blog about them at peter.orneholm.com. And yeah, it's I would say what I've heard from people at least is that that these services they are so easy to get started with. So if you have a hobby project, it's very cheap, and if you have an MSDN subscription or an Azure free subscription, you can get quite far with that, you can do quite funny things with it, and quite cool hobby projects with not that much time invested. So if you do any fun thing with it, please ping me as well. It would be nice to see what other people come up with.
Yes, and and actually I would have posted some of your links, some of your blog posts links in the chat if I would have been able to do it, but it seems to be something connected to my account. But I will take over the screen now, Peter.
Yep.
but please stick around. Just to show what we had some questions about the hack the climate, and I also want to share the Discord links again and let you have another chance at taking the badge. So bear with me, I'm doing my share here. So let's see. Let's start with allowing you to grab the badge. Now I'm not able to share the link here, but we'll share it on the social media, of course. So you can always follow us on hashtag Azure Skåne. It will be on LinkedIn and on Twitter primarily. And you can, I will do a small list of the links there so you can grab them. But now you have the chance to grab it here. Then I want to promote the Discord again. And it's not a long URL. I'm sorry I can't paste it in the YouTube chat. But please feel free to grab it there. And also, this is recorded and you can find it on the Foo Café site, naturally. And then also this Hack the Climate. And you see the link in red at the below, hacktheclimate.devpost.com. And if you are participating, please let us know. It would be really interesting to see what you come up with. And you could probably use many of those services Peter has demonstrated now for any solution that you come up with. And actually, here we have most of the links. We also have a YouTube channel, and of course, this will be posted there. And as I said, the social medias, hashtag Azure Skåne. And with that, I would want to say thank you for this time. We will stop the recording. And big thank you, Peter. It was really interesting. Hopefully, we will have you back again at some time.
Thank you. Yeah, I'm actually on parental leave, so it was nice to be able to chat some Azure again. Even if I try to keep up with everything that is happening, and I try to look a few sessions from Ignite, it's nice to be able to talk a bit Azure again.
Yeah, then good to hear.
Yeah.
And with that, I would want to say thank you to everyone, and stay connected. Join the Discord. Join the meetup. Take care. Bye.